Hi, welcome back. In this session, I'm going to talk about functional interfaces and lambdas in Java. These are introduced in Java 8, so we'll start right away. So this session covers functional interfaces and lambda expressions, which are introduced in Java 8 once again. So these features are influenced from Scala programming language. Right. Let's move on. Anonymous inner classes recap. Right. Interfaces are implemented on occurrence basis or inline way using new operator on the interface, which is otherwise not allowed directly. Right. So I hope you understand. So this is just a recap. Basically, functional interfaces are all anonymous inner classes based concept. So we'll go ahead. So if you remember, anonymous inner class was like dependent on interface on the in the inline basis. They were, or on occurrence basis, they are implemented on the fly, right? They are implemented on the fly. So it's called, that's why they are called inline way, using the new operator. So they return an instance, and then we call the method on it. All right. So but yeah, so those were like having there was no rule, like there only one abstract method should be there in those interfaces for anonymous inner class to satisfy, but there could be more than one abstract method, right? But let's go forward and look at what does functional interface look like. So anonymous classes concept is extended to functional interfaces with a catch that it is having single abstract method only, right? Single abstract method. It contains only one interface method, only one. That is to stress. All right. Such interfaces are annotated using functional interface. Even though this is to just to satisfy the compiler, right? But even though if we do not follow functional interface and the interface is having only one abstract or single abstract method, that still works for functional interfaces. And this is all a part of like Java's functional programming. All right. So they evaluate a computed value, right? Let's move forward. Lambda expressions, right? Such functional interfaces then could be used to write lambda expressions. So lambda expressions are dependent on functional interfaces having single abstract method only, right? So we will see further. Function objects as first class citizens. Let's look at it. Function objects. What are these, right? Objects created from functional interfaces. As simple as that, to put in one line, right? So basically, when we create an instance out of an interface using new operator, but with an implementation that is inline, so that is not yet executed. But when we return, it returns an object. It's called function object. On that function object, we have to call a method that is a method that is there inside that functional interface. That is, but before that even is called, we impart the behavior, expected behavior to it. But then after, when the function object's method is called, then that behavior is executed. They can be assigned to a variable whose type is functional interface again. They can be passed as method arguments whose type is functional interface. Once again, they can be written as a return. They can be written as a return value. So Java 8 introduced Lambda expressions as we discussed. Let's look at Lambdas. Declaring what to do, right, instead of how to do, right? So it gives the cleaner, concise codes that leads to higher productivity. The stress here, or the important point, is concise codes. As we look further, they become reduced form. Suppose number of lines of code, like 8 lines of code, becomes 2 lines of code. So likewise, so it becomes cleaner and concise codes, and lesser concurrency issues, right? Leads to parallel programming, higher performance. You do not have to maintain the state, because you do not have to maintain the state, so it will least concurrency issues. In Lambdas, we don't have to maintain the state. That is the reason least concurrency issues occur, and this leads to we can do the parallel programming, which leads to higher performance. So suppose this is the Lambda expression here, very first Lambda expression, in brackets xy hyphen greater than x plus 5. In this case, this is the expected behavior. This is not executed yet, or this is not added yet. This is just a behavior, imparting a behavior to it, but it is not run yet. That will be in the next statement or so. So this is important. So here, if you see my functional interface MFI, see this expression, it goes on the right side. This is a Lambda expression which goes on the right hand side. So it returns what, right? My functional interface. So this is addition behavior, right? Addition operator. So we are imparting a behavior to it to work as add or sum when we execute the method on my functional interface variable. All right, let's move on. Let's look at the syntax. So it is nothing but looks like arguments. So brackets may apply, and if there are 2 arguments or more, but if it's 1, we don't need brackets. Around brackets we don't need. And on the right side, it's like this, dash greater than sign, and the code block will come. This code block is nothing but that is executed in the next statement, but not on the same line. This is just to impart the behavior, this code block, and it is backward compatible. So let's move on. We'll look at a demo, anonymous runnable, replace it by Lambda. So we will see 2 variations here. One is anonymous runnable, because runnable is a method that is runnable is an interface that is used by in the thread programming, multi-thread programming in Java. So and replace it by Lambda. So we'll look at it. So write an anonymous class implementing runnable interface, print simple hello world. All right. So I have that recorded, so I will put the video over there. Next one is write a Lambda using runnable interface, print simple hello world 2. So I have the recording over there. So this is a part of theory, but these are demos which I have demonstrated in separate videos. So you can look up the class like anonymous runnable test class. So if you look at here, we have anonymous runnable test class, we have runnable, right? And then we are this is the interface, right? And then we are implementing run method and printing hello world 1. And then we at this point of time we have got the functional interface run 1. In this case, runnable is the functional interface. If you see, this is functional interface. So then after this statement is complete, we just make it run, or you can use it thread and then pass this instance to start the thread. I'm just demoing it for purpose to run. It is not the way to run a thread actually, but you need to create a thread instance and pass the run instance to the thread class, and then you can start a thread that way. And this is one way. Another one is to start like using Lambda. So Lambda here if you see, there is nothing, right? So if you see there, these are brackets, round brackets. If you see, these are round brackets here. This is just, we need to copy and paste here, and then put hyphen greater than symbol, and after that write the behavior system.out.println likewise, like this exactly. So just wait to part the, you need to write the implementation part or the code that executes. So so just need to copy this one once again here, and then put the Lambda symbol here, and after that copy this part and put it here. So it returns run2 and run, right? When you run it, you will print hello world 2. So these are this is the older way. This is the newer way with Lambda expression. So if you run it, there we go. Let's go back. So collections.sort, use the compare method, use string object and initiate a list of input data. Use anonymous inner class number 1, use anonymous inner class comparator. Number 2, use Lambda expression to replace anonymous inner class implementation. Okay, you can look at the test, demo class string sort test. So if you look here, we have a list of fruits, list of strings with fruit names, and we have here, if you see, this is a bit of a repeat, but then I have a separate video over there. This I just wrote with the collections.sort, right? And passing the fruits and new comparator, and then provide the implementation, right? But then how do you write using Lambda expression, right? Which is reduced to the single line. Here you can use collections.sort fruits string, and then this you copy, right? What do you do? Copy, right? This methods, the method that is implemented from the functional interface, right? Out of the functional interface, just copy that, paste it here, right? And then Lambda expression, and then exactly instead of this is return, right? So this is a return too. All right, so if it is return, it is a return, otherwise it's not a return. So if there is a return, it will return the value. All right. And the third way is to we don't need the data types in this case, you see. So we just need but still the other part is required. All right, so see how it is reduced, the number of lines. If you see 1 2 3 4 5 6, but now here it's only one line, right? So data types, why we don't need to provide the data types here. And one more thing before that is we don't need to declare this O1 O2 here. In fact, these could be anything, A, B or C, D, but these, whatever, if it is A, B here should be A, here should be B. If it's C or D, here should be, it should be reflecting here C and D. Okay, and so system.ornamental, and we are printing the fruits after that, right? So it is reduced. You might think why don't we put the data types here? Because collections.sort is the next one. Second parameter is a comparator, right? Comparator is itself a functional interface. All right, so comparator itself is a, if you look here, so comparator is a, look at it, here is a open declaration comparator class. It's a functional interface, you see. Yeah. All right, let's go back. So that's the reason we are using it to form the Lambda expression. All right, so if you run it, what happens? Apple, banana, kiwi, orange, right? These are sorted. So that's the way it works. All right, let's move forward. Other examples, this is for your own exercise, and adding an action listener to swings J buttons, right? Action performed is the single abstract method over there. So you need to print the messages for each case. Demo. Lambda expression for threads. So as you have seen runnable, this is the extension to it, but you just use the thread to use the functional interface derived from runnable interface. All right, you can look at it, Lambda thread test. So if you look at it, a new thread is created, right? And then we are creating a runnable interface, right? Because a new thread or thread constructor takes only runnable. So runnable, since it is a functional interface, so we are just providing the expression, Lambda expression to thread. So this one is goes to runnable, right? So runnable is a functional interface once again. So it has a run method. Run method doesn't have any parameters. So that one, this one is a Lambda expression, right? It is and it calls the static print message, right? And then Lambda and then this regular way, put the thread start and so on. So if you see when you see this one, hello Lambda thread get name, my thread name, and this first this message will be printed. Which one? Hello thread via Lambda, and then my thread name. Okay, let's run it. So my thread name, okay, let's look at the Lambda syntax. So arguments dash hyphen code block, right? For single arguments, no need to use brackets. For no arguments, need to use brackets. No need to do the declaration types, right? Data types we don't need to. Expression could be simplified for code blocks having single line expression. So these are the general rules. Multi-line expression, no simplification is allowed for multiple line, right? For single line expression, no need to have return statement since the evaluation is returned automatically, right? And no semicolons to the end, with also no need to use curlies. So for a multi-line expression, no simplification is allowed. Next one. Okay, I think we are almost reaching over there to the end. This is just putting a reference link for additional reading, so if you have time, please go through it.